I thought I would talk through the solutions for all you auditory learners. So on this first problem, you were given the function in one form, asked to change it to to standard form, or vertex form is what I would like to call that. So the first thing I did was the opposite of b over 2a, so I could identify the vertex. So I get negative 12 over 8, which is negative 3/2. If you substitute that into your function to find the y value of the vertex, you get 0. So, if you wanted to put a plus 0 on the end, I guess you could, but we wouldn't need that. So notice that our original function, we had f of x. So we have f of x equals ax squared plus bx plus c. Notice that the a, that's because it's the same value. So when you want to know what that, you don't have to solve for that. You just look and you know it's a 4. So then to plot this graph, the vertex is negative 3/2, 0, so you would mark that. Then using the parent graph, and this is stretched by 4, so over 1 up 4, that's probably all you'd want to plot, and then you'd want to put in your U-shaped graph. If you went over 2, remember the parent graph would be up 4, but this would be up 16 because we have to multiply by 4, and you probably wouldn't want to do that. You are asked to identify the vertex, which I have here. Find the x and y intercepts you're asked to find. So to find the x-intercept of any function, you let y equal 0 and solve for x. Well, it happens to be the vertex. To find the y-intercept, you let x equal 0. So you plug in a 0, you get 9, and that is the y-intercept. That is everything you were asked to find. So then that problem would be done. Okay, on number 2, a falling object travels a distance of d of t, and you have the function right here, feet, where t is in seconds. How long will it take for the object to travel 159 feet? So the 159 would be the distance traveled, so you're going to fill that in for d of t, and then you're going to actually solve this for t. So did a little bit of algebra there so you get 16t squared plus 5t minus 159 equals 0. I used the quadratic formula, but this actually would have been factorable, but I felt like it was faster to do the quadratic formula. Notice you get 2 solutions, a positive and a negative, but the negative one would not make sense for this problem since we're talking about how long, how much time. So you end up just going with the positive solution, which is 3 seconds. Now, I wouldn't have a problem with doing, well, yeah, because you could also do this on your calculator and find the zeros there, which is doable. But, make sure that you also know how to use the quadratic formula because that's pretty important. So on number 3, you were asked to solve the equation that I have kind of here in the brackets. And you can see the first thing I did was fraction busters. So I multiplied, the common denominator would be a 12, so I multiplied everything by 12. So 4 goes into 12 3 times, I get 3x squared. Multiply the 2 times the 12, 3 goes into 12 4 times the 4x. I have another quadratic equation, so I have to solve this quadratic equation. This one turns out it would not have been factorable. So when you do the quadratic formula, you will end up with a square root of a negative 32. So that tells you right away you're going to have an I involved. Remember how to simplify the square root of 32. It's the square root of 16 times the square root of 2, so you get 4 root 2. But because it was negative, it's 4i root 2. And then you end up with evens in all these spots, so you can divide out of 2. And then this would be your simplified answer. On number 4, we had a couple different ways to solve these, but by far the easiest way, if you have 4 terms like this, a cubic function with 4 terms, try putting it in a box and see if you can simplify it that way. This one you can. So you put 1 term in each box, pull out common factors. So I have x squared minus 144 times x plus 3 equals 0. X squared minus 144 is the difference of 2 squares, so you can factor that. Then that now we get plus or minus 12 or negative 3. So those are the 3 solutions for that problem. Okay, on number 5, it's, well, you know what the problem originally was, but my first step, this was a square root function I was solving, so my first step was to square both sides. When I square the left side, I get x minus 3. Over here, remember you're doing x minus 15 times x minus 15, so don't kill a puppy. So you multiply that out, do a little simplifying, you come up with this quadratic equation that you have to solve. Notice there's a lot of quadratic equations in here. Well, that's because we spent a lot of time doing that. So I use the quadratic formula, although I wouldn't have had to because this was factorable, but with the 228 there, sometimes it's easier just to do the quadratic formula. So I get two answers, 19 and 12, but you need to remember anytime you are doing square root functions that you have to check your answers, because in the process of squaring both sides, sometimes you pick up what's called an extraneous solution, and when you check the answer, it doesn't work. And the 12, when you check it, it doesn't work. So 19 is the only answer. So on an absolute value equation, the things to remember, first of all, you have to isolate the absolute value, so you add 5 to both sides first. Then remember you have two cases. So we have 2x plus 3 equals 6 and 2x plus 3 equals negative 6. You solve both of those and you get both of our answers. On number 7, an absolute value inequality. So again, you isolate the absolute value, so I add 5 to both sides. So then I have to remember that this symbol right here is when it's greater, remember spell it wrong, greater, so that tells me it's going to be an or. If it had been less than or equal to, it would be an and that makes a difference over here for my graph. So I have my two cases, x plus 1 greater than or equal to 9, or x plus 1 less than or equal to negative 9. Remember, when you switch it to a negative, you have to flip the inequality. So I get x greater than or equal to 8, or x less than or equal to negative 10. So this is my picture, and in interval notation, it would look like this. It's actually, you didn't have to do this graph right here, but it helps you to write it in interval notation, because negative infinity is this direction, infinity is this direction, and it helps you see the left, from negative infinity to negative 10. It's a bracket because it includes the negative 10, it includes the 8. Remember, you can never include infinity and negative infinity. Okay, on number 8, and I did have a few questions on this, and I kind of held off on answering them since I knew I was going to do this video. Here's our problem. We are trying to solve this inequality. So if you look through your packet, we had one where we dealt with rational functions, and we talked about top heavy, bottom heavy, powers equal. So, and we did a little interval work, and this interval work is going to actually help you solve an inequality. So you want to find the zeros. So you set the numerator equal to 0. And since this was already factored, we just get x equals negative 1. So that's important. You want to find where the discontinuities are, or the, let's call them what we call them then, vertical asymptotes. And that's where you set the denominator equal to 0. And we get x equals 5 and x equals negative 4. So you're going to use these values, positive 4. No. Okay, wait. Redo. Okay, so x equals 5, x equals negative 4, that's where the denominator would be 0. So you're going to take these values and you're going to put them on a number line. Then my little plus and minus signs, what that is, and remember when we did this with our interval work, we picked a number, like say I pick 0 because it's in between negative 1 and 5. Well, if I pick a 0 and I plug in a 0 here and here, I get a positive times a positive. Here I'll get a negative times a positive. So overall my answer would be negative, so I put a negative sign there. So hopefully this makes sense to you, otherwise you need to look that up in your packet. If I pick something bigger than 5, say 6, plug it in here, I get a positive times a positive and a positive times a positive, so that will be positive. I do that for each spot on my interval work, those are the intervals, and I am looking for where it's either negative or 0, because that's my solution to this inequality. So you can see where it's negative or 0, starting from the negative 4, but not including the negative 4, all the way through the 5, but not including the 5, because that's where it's negative or it's 0. And so that's why I have this written. This is actually my answer in interval notation from negative 4 to 5. Now, if this had just been less than 0 and did not have the equal to part, then I would have to say negative 4 to negative 1 union negative 1 to 5, because I would have to show that I am not including the negative 1. So that's not what this one says, but if it had said that, then I would be looking for I would have to exclude the negative 1. So hopefully that helps you, but you really do need to find that packet that we did with rational functions. So this next problem, this inequality, is a polynomial inequality, so not rational, but you'll notice I still did interval work because it kind of helped. So what I did was I factored out a GCF, because when you factor, that's the first thing you do is GCF, so I factored out an x. Then I took this x squared plus 7x minus 8. You can do a diamond problem. You could factor that, because that helped me find my zeros. So I have a 0 at negative 8, at 0, and at 1. So those were my zeros. Then I also did the same thing I did before with the negatives and the positives. So I plugged in something smaller than negative 8. So try a negative 9. You plug in negative 9 in each spot, and you'll get a negative. Because now all you care about is a negative times a negative times a negative. You don't care about what the answer is, but you know that that is going to give you a negative result. So I put a negative sign. Pick something between negative 8 and 0. It doesn't matter what. You can pick a negative 2 if you want. So if I pick a negative 2, I'm going to have a negative times a positive times a negative, which is going to give me a positive response, so I put a positive. So this is one way, continuing that. I'm looking now where it's positive, so you find where you've marked it positive. So it's from negative 8 to 0, which I marked, union from 1 to infinity, and I marked that. Now you'll notice I also sketched a graph using in behavior, because this is a cubic function, and it's positive. So I know this is the general, and I know where my zeros are. So I know that this is the general shape. Well, look where it's positive, where it's above the x-axis. Between negative 8 and 0, it's above the x-axis. Between 1 and infinity, it's above the x-axis. So that's another way you could look at this to decide where it's positive, because that's what you wanted in this case, where it's positive. Okay, so there was a lot to deal with on number 10. It actually took quite a while. So f of x is 1 over x minus 6. G of x is 5 over x plus 6. And the first thing I did for that one is I simplified this by adding these together. I multiplied to get a common denominator, so I get 5 plus 6x over x. I didn't use it all the way through, but I'll show you where. So for part A, you're adding the two functions. I did not find a common denominator. I'm looking back at this now. I'm like, oh, why didn't I do that? But okay. So how to get the domain? Well, they're rational, so you can't divide by 0. So x can't be 6, x can't be 0. And that's really all there was to that. You're just finding the domains. So basically, that means all real numbers except those. F minus g, change it to a minus sign. I could have done these. Change it to a minus sign. You would need parentheses around here though, because you're subtracting that whole thing. I could have written this in there instead. 5 plus 6x over, I could have done that. F times g of x. This time I used the f of x value, and then I used this that I had, the 5 plus 6x over x. But really nothing canceled anyway, so it didn't really do much for me. However, now I can say x can't be equal to 0 or 6. But then on the f divided by g, I took f, which is 1 over x minus 6, divided by this value I said for g of x. Remember that when you divide by a fraction, you can change it to multiply by the reciprocal. So then I get x divided by this product. So my domain, x can't be 6, and x can't be negative 5, 6. So that one, you would want to make sure that you, this was probably the trickiest, because you did need to find that common denominator and simplify this so you could figure out the domain. Also, I had included on there that the 0, you might look at this and say, well, wait a minute, you put 0. And that's because of this, because I also would have to still exclude the 0 because of my original function. I was dividing by that. So even though I ended up with an x in the numerator at the end, I had started out with it here, and so that still means I have to exclude 0 from the domain. Then f of g of x means you're putting g inside of f. So that's what I did here. And it looks like then I simplified that just by, these are opposites. 1 divided by 5 over x, change that to multiplying by the reciprocal. And we get x can't be 0. Again, because of this step here, we can't have 0 in the denominator. And g of f of x, we're putting f of x inside of g of x. So the 1 over x minus 6 drops into this spot where the x is. Then what I did here is I simplified this portion here, because that would be 5 times the reciprocal. Remember, changing division to multiplying by the reciprocal. That's where I got this from. And then distribute the 5, and you get 5x minus 24. Why did I exclude the 6? Back here, it was in the denominator, and the x minus 6, so that would have made 0 in the denominator of something. So that's why I had to do that. So hopefully that helps you on these first set of problems. It's all stuff you need to remember. And when you take your final this year, remember you do get to have open notes, open book. However, you still have to know how to do the problem. So anyway, hopefully that helps.